Hello, academic stars around the world. Welcome back to Caltex Academy. In case you're new, my name is Julius, and thank you for clicking on this video. Today on our board, we have a questions on the shortest distance between 2 points measured on the Earth's surface via the poles and along the grid cycle. In our previous video, we look at some formulae. The link of that video is in the description of our video here. So what is the question saying? So we have here point T and V are on latitude 20 degrees north and on the longitude 60 degrees west and 120 degrees east, respectively, as shown in the diagram below. So let me scroll up to get enough space and for our diagram to appear clearly. So here we have our diagram. You can see this is the longitude passing through point T and 60 degrees in the western hemisphere, and continue the other side here, passing through point V, cutting this latitude at 20 degrees north, and it is at 120 degrees east as illustrated up here. And let's check on the question. So the question says, calculate the part A of the question, distance between T and V along the cycle of latitude. So here we have the first latitude up there. And second part of the question B says distance between T and V via the North Pole. And we are advised to take the value of pi as 3.142 and r as the radius of the Earth as 6,370 kilometers. So how do you tackle these questions out? In our previous video, as I mentioned earlier on, we already had some formulae, but I can also try to figure out what we did last time for you to be able to follow along easily. Also, I have linked some printable PDF in the description of our video here. You can go ahead and download to follow along. Let's have this point subtended to the center of the Earth with O here, and also V. Then also we can join T to V via the center of the minor circle here with maybe center C. Then here we can maybe use a different color to illustrate our angle here. So let's call this angle as phi. So if this is our angle phi, again, let's go on and join this point. Let's call this point P and this one Q, and you can join it through the center of the Earth. And remember, this is the radius of the Earth. So what we need to also do here is to see that this angle is exactly our 20 here, meaning our alpha is 20 degrees in the northern hemisphere. So the same applies to here. We have 20 degrees. And for us to obtain through the North Pole, we need to have some angle here, and we can call this angle as theta. So I think this information is enough. We can go ahead and start solving our question. So since the first question A is saying we have to calculate the distance TV via this small cycle, what we have to do is to get this phi. So the phi is the angle difference. So since they're located in two different hemispheres, the western and eastern hemisphere, then we need to add the two angles. So we just need to ignore this west and east, just simply pick the values and we add together. So that is 120 degrees added to 60 degrees, and we just simply get 180 degrees. And once you notice that this one gives you exactly half of the circle, the easiest formula we can use to get our T, V here is just pi, capital R, cosine of alpha. This one is coming from taking this angle, that is 180 divided by the center degrees, which is also 360. So when you divide, you get a half. And remember also, circumference of the cycle is given by 2 pi and r. So here, the 2 will divide the half that comes from half of this circle. So at the end of the day, we end up with this formula. And that is what we explain. And please do check that video also in the description of our video here. So let us make a substitution to get the results for these questions. And we are advised to use phi as 3.142 times the radius of the earth as 6,370 times the cosine of our angle, and our angle here is 20 degrees. So therefore, TV is equivalent to, now when you put this into calculator, we'll get 18,807.51 555. So we can approximate this to 2 decimal places. Therefore, our TV through the eastern hemisphere is the same like through the western hemisphere, is approximated to 18,807.52, and that is kilometers. So that becomes the solution for the first question here. In case you have some small challenge, go ahead and leave a question in the comment section. I'll get back to you as soon as possible. So let's move on to the next question, and that is part B of the question that says, calculate the distance between T and V via the North Pole. Again, let's get back to our diagram. And from our diagram here, this is the distance required for us to calculate. Now maybe let me highlight it. We're moving from T through N to V, and that is the distance. So we need to see, is it shorter than the distance I've just gotten here, or is longer? We first need to calculate and we compare our answer. So let's move on and have solution for part maybe B here. And for us to get that, maybe we can make some small sketch that if this is point T and we are moving in that curve, maybe we land somewhere here, and we name this one here to be our T, we name this one to be our V, and let's provide enough space to have the center of the earth maybe here, and we join to our point V. We also join T to our center, and that is O. Now we need to get our angle here, and that angle is theta. How do you get theta? Again, we looked at getting theta using a small formula that comes from PQ as being straight line, and adding these two angles together, we make 180 because they're angled in a straight line. So to get theta, we simply substitute to this formula. I think it's a little bit brief. Theta is given by 180 degrees minus 2 alpha, and we already know that our alpha was 20 degrees. So you can simply input it in our calculator and we get the result out once. And if you don't have a calculator, don't worry, you can make this one here offhand because it's a bit quite easy. Multiplying 2 and 20, we get 40 degrees. So also feel free, like you know already our angle was looking like this. We have here theta, and we know this one here is 20 degrees. Also this one here is 20 degrees. You can go ahead and just add them normally, just like in geometry, where we had this 20 degrees plus our theta plus 20 equals to 180 because they're angles in a straight line. So summing up them together, we have our theta plus 40 degrees equals to 180 degrees. And then solving for theta, we subtract 40 degrees on both sides. So when we do that, the left-hand side, we're only left with theta. Here we get 140 degrees. This is the same way of doing that work here. Any of the two is accepted. So after doing that, what we have to do next is to make sure that our theta here is known to be now 140. And the radius of the Earth, R, we know is 6,370 kilometers. So we can go ahead and get our distance here. Remember, our distance is this one. And also, we also know that our N as the North Pole is somewhere here. So the question says through the North Pole, and our pole, of course, lies up there, as you can see from the diagram here. So this is TNV. So moving forward, since we have the radius of the Earth, then we can get our T, N, and V by having the angle theta over, we can choose to write 180 degrees, and we multiply by pi r as radius of the Earth. Or if you wish, you can say your T and V is equivalent to theta over 360 degrees times twice pi and r. This is the simplified version of our first quoting here. So we have T and V is calculated from our theta, which is 140 degrees. We're dividing it by 180 degrees times the value of pi at 3.142 times the value for r, and that is 6,370 kilometers. So if you input this into a calculator, then let's get some more space here. We get an answer of 15,560 6.86 kilometers. So we can approximate this to two decimal places, and we have TNV is approximately to 15,566.87. That is in also kilometers. So this becomes solution for part B of our questions. Thank you for watching up to this time. Remember, in our PDF that is linked in the description of our video, I have also given you some exercise there. You try to work it out and come back, share with us your solutions, and we'll be happy to see what you have gotten. If you get stuck, don't hesitate to come back and watch the video. I've also linked the link of this video back in the PDF there, or you can come back and also watch it and work it out. And remember the challenge in our exercise, I've taken a small cycle in the southern hemisphere. So see you in the next video. Peace out.